Picture this. You've got a multi-billion-dollar vessel, a total marvel of engineering, and it's holding its position with absolute pinpoint accuracy right in the middle of a raging sea. You've got powerful thrusters, super complex control systems, a crew of hundreds, and every single one of them depends on just one thing, a constant, unwavering flow of electricity. So, in that exact moment, what do you think is the single greatest threat? You might think it's a rogue wave, right? Or maybe some kind of catastrophic mechanical failure. Well, the real answer might surprise you.
Nope, it's not the storm. The real enemy is something way more subtle, something that can happen in quite literally the blink of an eye.
Because the real catastrophe is the loss of all power for just 1 second. That's it. A 1-second blackout can send the vessel's dynamic positioning system into a tailspin, shut down its drilling controls, and just plunge the entire operation into total chaos. You see, that single second is the razor's edge between control and absolute disaster. The entire system is engineered to prevent that 1 second of darkness from ever happening. And the hero of that system? It's a device you might actually have under your own desk, just, a whole lot bigger. This hero device is called a UPS, which stands for Uninterruptible Power Supply. Now, the official definition from the International Electrotechnical Commission describes it as a system designed for one core purpose: to maintain the continuity of load power. In other words, no breaks, no gaps, no interruptions, ever. The best way to think of it is like the ultimate power bridge. When the main power from the ship's generators flickers or hiccups or fails completely, the UPS instantly, and I mean instantly, bridges that gap. It draws from its own energy reserves to make sure the critical systems never even know there was a problem. Okay, but are all these power guardians created equal? Not even close. And when you've got a vessel where lives and literal fortunes are on the line, the difference between them is, well, it's everything. And here is the absolute key difference. A standard standby UPS, the kind you might have for your home computer, actually has a teeny tiny interruption. We're talking maybe 4 milliseconds, as it switches over to the battery. But on a ship like this, even 4 milliseconds is an eternity. It's just too long. That's why they use what's called an online UPS. With an online UPS, the critical equipment is always running off the UPS's power. That means there is zero interruption. Zero. It's the undisputed gold standard for these systems. So how does it pull that off? Well, an online UPS basically creates its own private, perfect little power grid. It takes the ship's dirty AC power, converts it to clean DC to charge its batteries, and then uses something called an inverter to create a brand new, perfectly stable AC signal for all the sensitive equipment. The upshot is the important stuff is totally isolated from any spikes, dips, or other junk coming from the main generators. It's like a firewall for electricity. But even with this absolutely brilliant system, there's a weak link, and you might be surprised what it is. A major industry survey found that the #1 problem wasn't the complex electronics, it was something much more basic. The report said, the principal reported problem has been unexpected battery failure. Can you believe that? The very heart of this Guardian system was its most common point of failure. This, of course, leads to a really critical question. In the tough, unforgiving marine environment, what is the battery's greatest enemy? What's taking them out? The answer, believe it or not, is heat. It's that simple. As a battery's operating temperature goes up, its expected lifespan just absolutely plummets. I mean, look at this chart. A battery that's designed to last for years can fail in a tiny fraction of that time if it just gets a little too warm. The numbers here are just stark. Research shows that for every 5 degrees Celsius you go above the optimal temperature, the battery's lifespan can drop by a staggering 20%. It's this brutal and relentless decline. So the logical question is, okay, if the battery is the weak link and heat is the enemy, why not just build one massive, perfectly cooled, totally infallible UPS to power everything? Problem solved, right? Well, not quite, because in high-stakes engineering, there's a golden rule. You can never, ever have a single point of failure. If that one perfect UPS failed for any reason, you'd be right back at square one. Disaster. So the real solution isn't a stronger Guardian, it's having more than one. The solution is a beautiful concept called redundancy. Here's how a truly resilient system is built. All the critical equipment is split into 2 completely independent groups. We'll call them A and B. You can think of it like the ship having 2 hearts and 2 nervous systems. UPS-A powers all the A systems, and UPS-B powers all the B systems. They are physically and electrically separate. So if anything, and I mean anything, in the A system fails, the UPS, a cable, whatever, the entire B system just keeps on running without missing a single beat. So making sure that 1 second of darkness never ever comes isn't about some single magic box. It's this strategic dance of really smart system design, carefully selecting the right technology, and just relentless, unforgiving maintenance, especially of those super temperature-sensitive batteries.
All right, so let's just quickly sum up the big takeaways here. First, a single second of power loss is not an inconvenience. It can be a full-blown disaster at sea. Second, online UPS systems are the gold standard because they provide that perfect, unbroken stream of clean power. Third, the biggest vulnerability is often the humble battery, and its greatest enemy is heat. And finally, the ultimate safety net isn't one perfect system, but redundancy. It's all about creating those independent lifelines, so one failure is never, ever the final word.
Kind of makes you wonder, doesn't it? What other complex parts of our world, from the data centers that run the internet to the air traffic control systems that guide our planes, how many of them are completely dependent on these silent, redundant guardians, constantly fighting this unseen battle just to keep our modern world from falling into darkness?